This is a problem from your lab assignment from section 3.3, problem number 1. A mass on a spring vibrates horizontally on a smooth surface, and the equation of motion is given by this function. X of t is equal to 6 sine t, where t is the time in seconds and x is in centimeters. So here's our visual of that. And for the first part of this exercise, they want us to find the velocity and acceleration at time t. So the velocity and acceleration are the first and second derivatives. If the equation of motion is given by f of t, then the velocity is going to be given by the first derivative, f prime of t, and the acceleration is given by the second derivative, f double prime of t. And so we will be looking for the first and second derivatives of this function. Our first derivative is going to be the derivative of this 6 sine t function. Well, 6 is a constant, so we'll leave the constant out there. And then the derivative of sine of t is cosine of t. So now that we're looking at this derivative, we want the derivative of the derivative, and so that's x double prime of t. And we need to take the derivative of x prime of t. So again, we have 6, and then the derivative of cosine, this time it's negative sine of t. Now we could have placed the negative sign outside if we wanted to, but either of these should be correct. So that's the end of the first exercise, finding the velocity and acceleration. Now they want us to find the position, the velocity and acceleration of the mass, and they give us a specific time here, pi over 3. In what direction is it moving at that time? So it looks like this is 0, this is x, and it's going to be oscillating back and forth, and we'll see that if it's positive, it'll be moving in a positive direction to the right, and then negative would be going to the left. We can confirm that after we work things out. So the position function is 6 sine t, and so we want to put pi over 3 in for t, and so that's x of pi over 3 is equal to 6 times sine of pi over 3. What's the sine of pi over 3? The sine of pi over 3, it's going to be root 3 over 2. So we'll put root 3 over 2 there. And here it looks like we just want to cancel or simplify. 6 goes into 2 3 times. So we have a 3 root 3 for our position. Now that we have our position, we'll find the velocity. So to find the velocity, we take the first derivative of the position, we get 6 cosine t. And so the velocity at time t equals pi over 3 is that 6 cosine t evaluated at pi over 3. So cosine of pi over 3, I think it's 1/2. 1/2 times 6 is 3. Oops. Oh yeah, that's good. And then finally, the acceleration is given by negative 6 sine t, and then we'll put pi over 3 in for t. Again, sine of pi over 3 is root 3 over 2. And then simplifying this, here we get a negative value. 6 into 2 3 times, and then there's a square root of 3. And there we go. So we found our position, our velocity, and our acceleration. So note that the velocity of the mass at time t is equal to 3 so the velocity is this number over here, positive 3, is going to be bigger than 0, and therefore at this time the mass is moving to the right. So let's do our final check. And that looks good. All right, so hope this helps.